This video is to explain algebra tiles, and so that you will be able to complete the IXL assignment and get familiar with algebra tiles on the Monday that is following Thanksgiving. Okay, so first you have to understand just what they represent, and you will usually be given a key like this. And notice that these negative ones are all red. That's pretty common. These colors may fluctuate. Sometimes I've seen purple ones and all different sorts of colors, but usually the negative ones are all the same color, and it's usually red. Now, when they say that this is worth x squared, what they're doing is they're really describing the area that is being taken up. See, this distance is called x, and that distance on both sides, x times x gives you x squared, okay? Now versus this one, it's this distance, x, in this way, but then it's a distance of 1 on this side. So x times 1 is x. So it's actually kind of a description of the area being taken up by the tile. Okay, and then here's 1 by 1, so it's worth 1. And then the same areas apply over here. It's just that we're saying they have a negative value. So if you have one blue tile and one red tile, and you're adding them up, so x squared plus a negative x squared, what is that going to give you? 0, right? We call it a 0 pair when you have one of each color. They like cancel each other out, okay? Then I wanted to show you this because sometimes you won't see them in color. It'll be on the screen just in black and white, and then you should just look at the key. They always use this square, this shape, like a large square shape to be an x squared, and a small square shape to be a 1, and then a bar shape to be x. And then they'll use two different colors to show you the negative ones and the positive ones. So you might see them as shaded. You might see them, I've seen some like this that have like lines in the ones that are negative x squareds, that you can see that too. Okay, but get their meaning and then use them to describe what the polynomial is or to solve something. For example, let's go to IXL so you know what I'm talking about. Okay, so here on IXL, it's saying write a polynomial. What expression, that's what a polynomial is going to be here. What polynomial expression does this set of tiles represent? And it wants you to not just list a bunch of, like, there's 3 x's here. It doesn't want to say, it says don't do plus x plus x plus x. Make that into 3x. Combine your like terms, okay? So 1, 2, 3, 4, 5. That is 5 x squareds. So I do x, and then I use shift 6 to get the caret or exponent, but you could just use this blue thing right down there if you want to. And then I come over. Now the cursor dropped back down. That's good. That's what I want. And then I'm going to put in my 3 x's. So 3 x bars. Oops, I need a plus sign. Okay, plus 3x, and then plus a positive 1, 2, 3, 4, 5, 6, 7, 8, 9. And those are just 1. So this is the polynomial that represents this set of algebra tiles. Okay, we'll do another one. 1, 2, 3, 4, 5. We've got 5x squareds. Move over with the cursor and plus 4x, and then plus 2. Make sure you got those indications of either positive or negative or plus or minus in between your terms. Otherwise, it's going to be counted wrong, which is such a bummer. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 x squareds and plus 4x. Oh, that's an equal sign. That's not going to work. Here we go. And 1, 2, 3, 4, 5, 6, 7 plus 7. And good to go. Now let's jump to more difficult ones. Okay, so at 60, that's when it changes to having negative tiles. So it's really no different here. All of the the large square tiles I have are all negative x squared, so I'm just going to combine them. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Okay, so negative 9x. So if you're not careful, you're going to end up doing a lot more work. Just watching out for your signs and having those pluses in between or minuses. So plus just one x bar, and it's positive, so I say plus x. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, those are positive, so plus 10. And good. Oh, everything's negative. Okay, and I don't have any ones. Oh, that's no big deal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 9x squared. And then count carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10x. Okay, because they're all negatives here. So that's why it's minus 10x. Okay, see if it gets any more difficult. Oh, now they've got a combination. That's fine. So positive 1, 2, 3, 4, 5, 6, 7, 8. Positive 8x squared. And 1, 2, 3, 4, 5, 6, 7, 8. A positive 8x. And then, but these are negative. 1, 2, 3, 4. So minus 4. There you go. That's really not that difficult. So I'm already up to past 70. Let me see. I don't think it's going to get any more difficult than this, but I'll do maybe one more just so you can see it. Okay, then come over. Actually, I want to show you this. Like if you stay in the exponent and then you start going plus, do you see how it's a little up there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would go minus 10. Oh no, look. See, because I didn't move over my cursor. So don't do that. Make sure you hit the arrow key to move the cursor down. Okay, negative 10x and then plus 6. Okay, this just keeps going on and on. It's really not that difficult. So hopefully you have a good sense of it now. Thank you.